Hello friends, I'm back again with another session of chemistry, and today I am starting with practical chemistry but in parts. So in this first part of practical chemistry, I'm going to discuss with you the qualitative analysis chart, and then session wise we will proceed and see the details. So let me share the board, and with that we start the class. So here it goes. You can see the chart which I have already pasted here for you all. Now this is a group analysis chart, children. Group reagent and cation. Now today we are going to start with the qualitative analysis. Now qualitative analysis, when we are talking about, it deals with the conformation of cations and anions. But then we should be knowing some technical terms also. So for cation, we use the term basic radical, and for anion, we use the term acidic radical. The reason being very simple, that when you take a cation and you dissolve it in water, you get a solution which is alkaline or basic in nature. And that's the reason it is considered to be a basic radical. Whereas when we take an anion and we dissolve in water, it gives an acidic solution. For example, if we take carbonate ion and we dissolve it in water, you will get a solution of carbonic acid. Whereas when we take a basic radical, suppose K plus ion, which is the most active cationic species to be considered, it will form a strong alkaline solution, that is of KOH. Therefore, all your cations in water, they form a basic or an alkaline solution. Therefore, they are known as basic radicals, and all the anions in water form an acidic solution. Therefore, they are known as acidic radicals. Now we move to this chart. Now, whatever group analysis, qualitative analysis we are going to do, that entire chart has been divided into 0 group and group 1 to group 6. 0 group has been kept separately. It is tested separately. Rest, group 1 to group 6, when we are testing, we prepare a solution, and with that same solution, we keep on testing for the groups, which we will be doing at the latter part. Now, let's start. If I talk about 0 group, children, then in the 0 group, your group reagent is NaOH. Now, when we add dilute NaOH solution to a salt, if that salt contains a cation of 0 group, then how will you confirm? Through observations which we will be recording. So when we add dilute NaOH and we heat the contents, the solution smells of ammonia. Because the solution is smelling of ammonia, therefore it is predicted, it is suspected that the 0 group is present. But then the confirmation is done by passing the evolved gas through Nessler's reagent. When the Nessler's reagent turns brown on passing the gas evolved, it shows that 0 group is present. And once the 0 group is confirmed, then we confirm the presence of ammonium ion. Here, the testing of the 0 group and the ammonium ion is same. Then we move to group 1 to group 6. Now, if I talk about group 1 to group 6, for this we prepare original solution. Now, this original solution, children, it is also known as OS. This OS is prepared by taking the salt, and before we start the practical, we try to test the solubility of the given salt in the various solutions. We need to take the precaution part, which is the precautionary part, is that the solution should not be concentrated. It should be strictly acidic in nature. So here we use either dilute HCl or dilute acetic acid or dilute HNO3, but we don't use dilute H2SO4. Conc acids, I have already told you just now that we don't use in preparing the original solution. Yes, you can use distilled water depending upon the given salt and its solubility. So once the original solution is prepared, then as I mentioned earlier, that you will be adding the group reagent. If you get a particular precipitate, it confirms the presence of the group. And if you don't get the precipitate, it records the absence of the group. So let's see. Now for group 1, once the OS has been prepared, we add dilute HCl. If you get a white color precipitate, then it confirms the presence of group 1. If you don't get a white precipitate, it shows the absence of the group. Then we filter the solution, and with the precipitate, we test for the lead ion, which is a part of group 1. So the cationic part, how to test the conformation of the cations, we will be doing in the next session. Then in case if you are not getting the precipitate, then we, in that same solution, we pass H2S gas in acidic medium. Acidic medium means that first we will be adding dilute HCl, though you have added because it is the group reagent of the first group, but then again we will add and we will pass H2S gas. If we get a black precipitate, then it indicates the presence of group 2. Otherwise, it shows the absence of group 2. If it is showing the absence of group 2, in the same solution, we add solid NH4Cl followed by ammonium hydroxide or ammonia solution in excess, that is NH4OH. In this case, you can see I have written Fe plus 3 ion and Al plus 3 ion. Either of the cations are present. If you get a reddish brown precipitate, then it confirms the presence of ferric ion. No, it confirms the presence of group 3 because conformation of the cation is always done after the conformation of the group. So if a reddish brown precipitate is present, it confirms that the third group is present. We can always filter the solution and we can confirm the presence of ferric ion by its particular test. If I get a white precipitate in this process, then it confirms the presence again of third group. But because it is a white precipitate, so we will be confirming the presence of aluminium ion because aluminium salts are white in color. If we are not getting any precipitate, neither reddish brown precipitate, neither white precipitate, then we move to the fourth group. In the same solution again, it is saying H2S gas in the alkaline medium. We will again add some pinch of NH4Cl and ammonium hydroxide solution in excess, and then we will pass H2S gas. If you get a gelatinous white precipitate here, then it indicates the presence of fourth group. If you don't get any precipitate, then it shows the absence of the fourth group. Then again, in the same solution, we will be adding ammonium carbonate. Again, before adding ammonium carbonate, we have to make the solution alkaline. For making the solution alkaline, you will again add NH4Cl followed by NH4OH solution. If you get a white precipitate, it confirms the presence of fifth group. Now in the fifth group, there are 3 cations. We follow the order of BSC in confirming. That we will be discussing once we will be discussing the conformation of the cations. For now, if you are getting a white precipitate, it confirms the presence of the fifth group. Then comes the sixth group. If you don't get any white precipitate, it is indicating that the fifth group is also absent. Then in that case, we add disodium hydrogen phosphate, again making the solution alkaline. So if you get a white crystalline precipitate, it confirms the presence of magnesium ion. So you can see that we have tested with the same original solution, that is OS, from group 1 to group 6. But for 0 group, we do not prepare any solution. It is done by taking directly the salt in the test tube, adding dilute NaOH solution to it, heating the contents. If the solution smells of ammonia gas, then the 0 group is suspected. We pass the evolved gas through Nessler's reagent, and on passing the gas through Nessler's reagent, what will happen, children? You will get a brown color solution, which will confirm the presence of 0 group and ammonium ion. Because as I mentioned, for 0 group and the ammonium ion, the tests are same. So I hope this session was fruitful for you all. You have got a basic introduction about qualitative analysis, that how we will be going about qualitative analysis, how we will be confirming the groups. Now in my next session, once I will be taking, then I will be discussing one by one the confirmation of the cations. Till then, be safe, stay safe. Thank you.